Hey guys, so this video is me doing the study guide so you can see the ways to do the problems and the answers to the problems. So without further ado, here's the study guide. So it says select all ordered pairs that satisfy the function. Now remember, an ordered pair is an x value and a y value, meaning if you plug in a 2 for x, does it equal a -1 for y? An x value and a y value on each one. So if I plug in a 2, 3 times 2 is 6. 6 minus 7 is -1. That works. I plugged in a 2, I got out a -1. If I plug in a -1, 3 times -1 is -3, minus 7 is -10. That's a +10, that doesn't work. If I plug in a 0, 0 times 3 is 0. 0 minus 7 is -7. That works. If I plug in a -2, 2 times -3 is -6. -6 minus 7 is -13. That works. So your answers are A, C, and D. Which of the following relations represent functions? Select all. So you got to watch out for that. So there's probably more than one that apply. So remember, it has to be one input, one output. That's what you're looking for to see if it's a function. 1 to 1, 1 to 1, 1 to 1, 1 to 1. It's okay if they repeat in the outputs. That's fine. But that is a function. Y equals 5x plus 4. We have an input, an output, an x, and a y. That's a function. Now remember, on graphs, if you do the vertical line test, meaning if you draw a vertical line down the middle, if it hits it more than once, then it's not a function. So that means one input and two outputs. Same here. If I plug in a 2, I should only get out one number. But in this case, I get out a 2 and a 5. That is also not a function. All right. Number 3. Create a graph of the function using this table. All right, so if I take all of these and plug them in, I can get some y values, which will give me points that I can plot. So -2 times 2 is -4. -4 minus 3 is -7. -1 times 2 is -2. -2 minus 3 is -5. 0 times 2 is 0. 0 minus 3 is -3. 2 times 1 is 2, minus 3 is -1. 2 times 2 is 4, minus 3 is 1. Now if I take each of these points and plot them, -2, -7, it's going to be off the graph, -1, -5, 0, -3, 1, -1, 2, 1, I get them all in a nice straight line looking like that. All right. On to the next one. Which table below represents a linear function? Now remember, linear means a line, and it has to be consistent on both the x's and the y, the changing. So like, for example, the x's are changing by 1, changing by 1, changing by 1. The y's are changing by -1, -1, -1. They're the same every time. That's linear. Let's go B, so it's going from -2 to 1, so that's going up 1, up 1, up 1. This is going down 3, down 3, down 3. It's consistent. That is also linear. I'm actually afraid this might actually not be linear. We'll find out. 0 to 1 to 2 to 3. It's going up 1, up 1, up 1. -1 to 2, that goes up 3. 2 to 5 is up 3. 5 to 8 is up 3. That is linear also. I wonder if this last one's going to be linear. So that's up 1, up 1, up 1. This is down 3, down 3, down 3. And this is why you check your math before you do. That's also linear. So all of them are linear. Yay, A, B, C, and D is the answer. What would happen if it wasn't linear? You'd have like 1 to 3, 1 to 3, 1 to 5, and all of a sudden it's not consistent, making it not linear. All right, a swimming pool has 80 gallons of water in it. Water is added to the pool at a rate of 4 gallons per second. So remember, y equals the initial value. So 80 is where we start, and we're adding water. So we're adding water at 4 gallons per second. Now we don't know how many seconds it's going to go for, so that has to have an x there. So there's our equation. So now we just go over there. In this case, it's a t representing time. And it looks like that right there is my answer. Yep, so far so good. All right, number 6. 3 friends are saving money for a class trip to Washington, D.C. Frank has $90 in the bank, and he's adding $80 each month. So he has y equals, he's starting with 90, and he's adding $80 each month, and we don't know how long for. So there's his equation. This is Eric's. Well, Eric, where does Eric start? So he starts at the very beginning when it equals 0, so he has $20. $20, and what's he adding? So every 4 months, he's adding 20 to 240, 240, 240. So every 4 months, he's adding 240. 240 divided by 4 is 60. So that he's got $20 to start with, and then he's adding $60 per month, and we just don't know how long that's for. So there's his equation. And this one says that he has $55 to start with, and then he's adding $85 per month. Now we can answer the question. It says, person saving money at the fastest or the greatest rate. So this one's 80, this one's 6. Rate is always with the x. Remember, it's always with the x. So 80, 60, and 85, well, right there, that's Sam. Okay, person saving money the slowest, 80, 60, 85, it's the 60, $60 a month, that's Eric. Person with the largest initial amount, so he starts with 90, he starts with 20, he starts with 55, so it's Frank up top with $90. And then the person with the smallest initial amount, 90, 20, 55, it's the 20, which is Eric. So your answers are Sam, Eric, Frank, Eric. All right, here's the next one. 2 functions are shown below. Which statements about these functions are true? Select all that apply. So we need to know the rate of change and the initial value looks like. So the rate of change right there is 3, rate of change, ROC, and the initial value, IV, is 9. This one starts where x equals 0. So here's the 0, so the initial value is right there at 9. Okay? Now let's look at the growth. From 1 to 8, it's going 1 to 9, it's going up 8. 9 to 17, up 8. 17, 25, 8. 8. Negative 2 to 0 is up 2, up 2, up 2, up 2. So this is saying that it is changing 8 for every 2. 8 for every 2 is the same as 4 for every 1. So right there is my rate of change, which is 4. So the equation would be y equals 9 plus 4x. Now we can answer the question. So the rate of change is 3 for both? No. The rate of change is greater for A than B. Well, A is 4, B is 3, so yes. So the rate of change is greater for B than A? Well, nope. The initial value is 9 for both of them. 9, 9, yes. The initial value is greater for function A. Well, we just showed that they were the same, so no. And then both are linear. Well, that's consistent. That has no exponents. Both are linear, so your answer is B, D, and F. All right, on to the last one here. 2 movie clubs charge an initial membership fee plus a constant rate for each movie that is rented. The table and graph show what the 2 movie club charges. Okay, it's kind of like Prime Video, where you pay the Prime membership, but then you also have to pay to rent some movies. So in this case, create an equation to represent each relationship. So where does this graph start? It starts right here at 4. So it's y equals 4 plus something. So to get from 4 to this dot, it goes from 4 to 6. So it goes up 2. So it goes up 2 and then over right here 4. Well, 2 to 4 is the same as 1/2. And what's 1/2 of $1? 50 cents. So it's $4 plus 50 cents per movie. So there's your first equation, y equals the $4 plus 50 cents a movie, and the x, because we don't know how many movies you're getting. All right, $3.25 to $4.75, that's a $1.50 increase. $4.75 to $6.25, that's a $1.50 increase. So we're increasing by $1.50 for every, looks like, 2 movies. Well, $1.50 divided by 2 is the same as 75 cents. All right, so there's my rate of change, and it all starts at $3. So you have to pay $3.25, and then you have to add to it 75 cents per movie. So there's your equation right there. All right, that's the study guide. That's the answers. Good luck.